Welcome everyone. So in this video, I am going to address the chi-square test for association, otherwise known as independence. And the chi-square test is oftentimes used when you want to draw a conclusion about two or more categorical variables. You want to compare them, you want to know if they are related somehow or if they are not. The process we use, it is always a four-step process. I'm going to walk you through all of those four steps. And I'm going to walk you through an example so you know what to do from start to finish. Okay? So I have in here an example. So the National Gun Policy, they surveyed a bunch of people, and the question they posed to them was, do you think there should be a law that would ban possession of handguns? And they recorded the responses, okay? And what they did is they stratified by educational level. So you have people without high school diploma, there are 116, and those with high school diploma, and some college graduate students, and those with postgraduate degree. And these are the people that said yes, that they would prefer to ban the handguns. And these are the people that said no. So the information that was given to us is this information. Before you even begin, the very first thing you should do is do what we call a marginal distribution, or draw the margins, expand your columns and your rows and come up with these totals. So if you add 58 to 58, you get 116, and so on and so forth. Notice that if you add these two and you add these 4 or 5 values, you should get the same value. Let me call this the grand total, because these are all totals, but this is the grand total I underlined twice. So let's read this carefully. So this, let's say this 213 represents all the high school graduates who were asked the question. Regardless of what they said about the handgun, these are all the people that were asked the question who have just finished high school. And let's say this 715. This 715 stands for the number of all the adults that said they don't approve of having a handgun ban, regardless of their educational level. Make sense? So make sure you understand what these 5 and 2 numbers stand for. Okay, so let's begin. The first thing we do is step 1, is to state the hypothesis. And the hypothesis is always of 2 types. Either a null hypothesis or the alternative hypothesis. So in our case, the null hypothesis, which is the neutral statements, it would mean that there is no association between the educational level and the response to the handgun ban. And for the alternative hypothesis, we would say that there is an association. Okay? Now, you can go back to stuff you've done in the past, and you can do a bar graph, right? You could do a bar graph or a pie chart, and you could probably, with the naked eye, decide whether or not there is an association. But when things are a little sticky, when the numbers are not too far apart, it would be very hard for you to make that decision, and hence the chi-square test for association. So the first step is to state your hypothesis. Before I go to the second step, I love to locate myself. Figure out what tests are you using and why. So, and I just called it locate yourself. This is basically a chi-square test for association. There are 3 types of chi-square tests, and it's so important from the problem to realize what kind of a test you're going to run. I have already told you what it is, so this is kind of silly. But generally speaking, you need to know what kind of a test are you running. All right? Step number 2, what we do is we check some conditions. Oftentimes, for example, when we discussed the normal distribution, we had to know whether or not the distribution is normal. Because if the distribution is normal, we wouldn't have the rights to assume normality and do the calculation, right? For the chi-square test, we check three conditions, okay? And if any of these three conditions is not fulfilled, we shall either proceed with caution or completely not use the chi-square test because the conditions are not fulfilled. The first one is obvious. You want this sample that they picked of people, 1,201. You want to make sure that this sample represents the population of interest. So when I read this, it says, the National Gun Police Survey asked a random sample of adults. Now, when the book uses the word random, they mean a simple random sample. But when I read it, I assume this is not a good sample. And to be sure, I have to make these statements and say that we're not sure if the data comes from a well-designed experiment. We have no idea how the sample was obtained, and therefore we shall proceed with caution. Okay, you don't want to stop and say, okay, well, I'm not going to use the chi-square distribution. You just need to make a statement like this one and proceed with caution. The 10% condition is another condition that basically says you want the population size to be at least 10 times the sample size. Now, they told us that the sample size is 1201. That's the grand total, right? Whether you add these numbers or these numbers, you get 1201. So I am assuming that there are more than 12,010 adults in the community from which they surveyed the people. So I'm making that assumption. In most places there is more than 12,000 people. Like even a small city will have probably more than 12,000 people. Okay? Now, this condition sometimes can be bypassed. And we would bypass the condition if, let's say I ask a particular person, let's say a high school graduate, I ask a particular person, and they give me the answer. They are of the opinion to ban or not to ban. And what I do with that person, I put them back in the pool. In other words, there is a chance that I might pick them again. If this is done with replacements, which means put back the person you have just asked, put that person back into the pool, if that is the case, you don't need to check the 10% condition. We assume that the moment you ask a person and they give you an answer, you don't interview them again. They don't have another chance. They walk away, right? And they're not back in the pool. And if that happens, then you need to check the 10% condition. The third condition is called the large counts. And that is all expected values are greater than 5. Okay? So, how do we figure out these expected values? I'm going to show you how to do this in two ways. The first way is to do it by hand. So we have, if you look here, we have 58 people without a high school diploma that approve of a handgun ban. That is observed. These numbers are observed. These are people who told us. For example, 135 people do not approve of the ban, and they happen to be college graduates. So these are observed values. And we can figure out the expected value. So every observed value has an expected value associated with it. So if you want to know the expected value that represents kids without high school diploma who approve of the ban, what you do is you go to this number and you go to that number. What you do is you multiply this number by this number and divide it by the grand total. So the expected value, I'll put it in green. The expected value that represents the observed value called 58 is 116 times 486 divided by 1201. Notice this is a ratio. This is a percentage times a particular number. That gives you the expected value. You can also look at it this way. A ratio or a percentage multiplied by a particular value gives you the expected value. Okay? And you will understand what the expected value is. Another way of saying the mean. You will understand, I'm going to explain this later. Why is it that we multiply this value by this value and then divide by the grand total? So if I want to know what is the expected value that corresponds to 135, I'm going to multiply 233 by 715, and then I'll divide all of that stuff by 1201. When you multiply this by this and divide by that, you should get 4694. So I have already computed the expected value for all these 10 observed values, and I wrote them in here. Now, I didn't do this by hand. I used the calculator, but I did double check the first one to make sure that it matches 4694. So this is 4694, okay? You don't want to do this by hand. You should know how to do it, but you don't want to do this by hand. You could just use the calculator. All right. So, and by the way, these expected values are useful for two reasons. Number one, to check the large counts. So if you look at these expected values, they're all more than 5. So this condition is checked. This condition is checked, and this one is a little iffy. We're not sure. So we shall proceed with caution. All right. So the third step is to perform the calculation, the math. And basically what you need to do is find two values. Let me show you a picture first. Let me show you a picture. So the chi-square distribution looks like this, okay? And as you can tell, it's skewed to the right. The chi-square distribution is always skewed to the right. And what we want to do is find two values here. One is called the chi-squared value. This is called a test statistic. And once you find this chi-squared value, which is a position, think of z and x when we dealt with the normal distribution. It is just a location. We want to find the corresponding area. It's called the p-value, okay? How do you compute the chi-squared? You take every expected and you subtract the corresponding observed, and you square it and you divide it by the expected and you add them up. For instance, the way you do it is you take this observed or expected, which corresponds to this one, right? You take this expected minus observed, square the whole thing, divide by the expected. And then you move to the next one. You take the expected corresponding to 84, which I didn't do, subtract the 84, square the whole thing, and divide it by the expected value. And then you go to the next one and you add them up, and you just add them up, and you get 8.525. I will also show you how to do all of this on the graphing calculator. It does take time to do it by hand. Let me just do the first one. So we have 4694 and 58. So basically you have 4694 minus, forgot the number, 58, expected minus observed, squared over expected. That's just one of them. And then you go to the second one. And then you go to the third one. And how many are going to add? There are 10 of them. 10 terms, right? There are 10 terms. When you add them up, you should get 8.525. 8.525. Now, once you find this location, and I'll put it here for you. Sorry, it's here. Chi-squared value is 8.525. So this is the location. The next thing I want to do is find this area in blue. To the right of the location, it's called the p-value. So the p-value is the probability that the chi-squared is more than 8.525. And I got 0.0741. Again, I'm going to show you all of this on the calculator. Okay? So that means this area here in blue is 0.0741. I basically exaggerated it so you can see it. It's really a tiny area, right? The chi-squared is really here, but I want to make sure that you can see. So it's basically the area to the right of this particular location, okay? Now, we need a cutoff, just like we did with the normal distribution. So let's just assume that the cutoff, don't worry about degrees of freedom, I'll come back to it. Let's assume that the cutoff is 5%. It's called significance level. So if my significance level, if my cutoff is 5%, which is smaller than 0.07, right? So this blue area is 0.074, right? I hope I'm so forgetful. Yeah, 741. Okay. Clearly, this blue area is more than the area in black, right? That means if this is my cutoff, my location here didn't cross over. And if you don't cross over, it means you do not reject H null. And I'm going to pause here for a long time. If you don't cross, that means you are willing to stick with the null hypothesis. And I'll explain in great detail. So, why is it true? So imagine, so here's the chi-squared value. The chi-squared is expected minus observed squared over expected, let's call it 1, plus expected 2 minus observed 2 over expected 2 squared, ... right? Now, chi-squared here is 0, isn't that true? Chi-squared is a location. So at this point, chi-squared is 0. Where is chi-squared 0? What does that mean? If this is 0, that means this plus this plus this plus all of them is 0. But notice these are all positive quantities, or 0. They cannot be negative, because that's a perfect square, okay? And the expected value is a positive value. So every term is positive, and they add up to 0. What does that mean? That means each term must be 0. Each of these terms must be 0. So what does it mean to say that this term is 0? It means the top must be 0 because the bottom is already positive. For the top to be 0, that means E1 minus O1 has to be 0. That means the expected value must be the observed value. And this expected value must be the observed value. And the next expected value must be the observed value. What does that mean? That means if the observed value of kids without high school diploma said yes, 58 of them said yes, and the expected value is also 58, what you observe is what you expect is exactly what you observe. That means there is no association. Does that make sense? In other words, the closer you are to this location, the more likely you are not going to reject H null. You're going to stick with it, right? We notice that this chi-squared is to the right of the cutoff. This is my cutoff because this area is smaller than that area. That means this location is smaller than this location. That means I didn't cross over. This is the cutoff. If chi-squared is here, that means you reject H null. If chi-squared is to the left of this cutoff, that means you don't reject H null. So according to my calculation, since the p-value is greater, I'm talking about area here, we fail to reject H null. and then make sure you draw the conclusion in the context of the problem. That's your step 4. We will conclude that there is no association between the level of education and opinion about handgun ban in the adult population. Okay? And that should end the story, because that is exactly what we want to investigate. We want to know if you're going to accept this claim or are you going to stick with the null hypothesis. That's the whole point. And we believe, according to this calculation, we believe that there is no association between the educational level and how people responded to the handgun question. Okay? Now, the thing I didn't do, of course, I know you know how to do this by hand, even though it takes time. But we don't know how to do this by hand. And I know you know how to do this by hand, right? What you don't know is this. And degrees of freedom, by the way, it's kind of irrelevant to this problem. But degrees of freedom for the test, chi-square test for association, you take number of rows minus 1 times number of columns minus 1. So we have 2 rows and 5 columns. So when you multiply 2, this is 2 minus 1 times 5 minus 1, I get 4. There are 4 degrees of freedom. It is kind of irrelevant to the problem unless you use the back of the book, right? But since we have access to the graphing calculator, you really don't need this. But you do need to calculate this, because this is always compared to alpha to make a decision. So how do we do it? Here is the good news. Not only that we can get this for free, and that's for free. Even though you can do this by hand, you will get it for free. And even though you can do this by hand, which takes time, you will also get it for free. You'll get all of them for free. And here's how you do it. And I will conclude the video with this step. So basically, I'm going to redo step 3. Step 3 is the calculation, okay? Step 3, including, by the way, these. I'm going to include these as well, using the calculator. And here's how you do it. You go to matrix, which is on your calculator. You click on edit, and you input the size of the matrix. Remember, the size of the matrix was a 2 by 5. So you enter, it's gonna give you like a blank, right? So you do 2 times 5. It's a 2 by 5. Think about it, right? We have 2 rows and 5 columns. So make sure you enter the right size of the matrix. And after that, you go to stats, you go to tests, and there are many chi-square tests there. You go to letter C, which is chi-square test. You click on calculate. Don't look at the blue. You click on calculate, and you get all of them. You'll get the chi-squared value, which is 0.0741. You'll get the p-value. You get the chi-squared value, which is 8.525. You'll get the p-value, which is the corresponding area to the right of the location 8.525. Happens to be 0.0741. You get the degrees of freedom, which wasn't hard to do anyway. And you get so far that's what you get. And that's all we need from this calculation to draw the conclusion, true or false. Now, after you do all of this, you can actually get all the expected values separately. Not only that you get the sum, but you get all of them separately. This plus this plus this plus this, right? Makes sense? All right. So here is how you do it. And I will conclude with this. You click on calculate. I erased it. Sorry. I'm almost done, okay? Calculate. Okay. After you click on calculate, you're going to get those numbers for step 3. After that, you can go back to stats and click stat test C. And instead of clicking on calculate, you click on draw, and you'll get this picture for free. Remember, you're not going to be able to draw until you click on calculate and get these values first. After you get these values, go back here and go through the steps again, and you'll have 2 options. You want to click on draw. I'll put a slash. Click on draw, and you'll get a nice picture, which is helpful. Then, whether you just do this or you do both, it doesn't matter. The key is to finish the calculation. Go back to here now. Okay? Don't do this before. You do it only after you do all this or after this. Go back to matrix, click on edit, right? And you're going to see, after you click on edit, or after you click on matrix, you see all the names of the matrices, A, B, C, D. Now the A matrix is the one that occupies this 2 by 5 that you did already. What I would like you to do is click on B and click enter, and you'll get all of these for free, which is nice. Okay, so you don't have to do them by hand. So that should end the story of today's presentation. Sorry, it's a little long. And once you start practicing this, it'll become like second nature. All right, take care.